In this question, the function f of x given is the natural ln of x. This is defined for the given the domain is natural number and codomain is the real number. And g of x function is given. This function is defined for the domain R. This function domain is R. The codomain is integer is given. Now we are going to check the f circle G. This composite function is defined or not. How can you check it? G second function codomain. What is the second function codomain? This is Z. Second function codomain should be subset or equals to the first function domain value. So first function it is false only na. So integers are not subset or equals to the natural number. That's why it is not a composite function. So that's why we can prove by the counter example. Simply, how can you prove it? So any codomain value which are not belongs to the domain, okay, na, which not belongs to the domain of the first function, we can say so it is not defined. That's why I am taking an integer. See, what is that second function codomain value? I am going to take the 0. Okay, I am going to take the 0. Is okay na? Will I get 0 or not? By using function only we can check it. I am going to take the codomain value is 0. 0 is there. But 0, according to this function, we getting the 0 or not? Yes. If I put the input value, if I take the, yes, in this real value, 0 is there. So in that input, if I substitute in place of x, I got the 0. Yes. So this 0 is the codomain of the G function. Okay. This is now what I am going to do. This is not domain in the set of domain value. Okay, na? This value, this 0, which is not, now I am going to write it, 0 is not in the domain of natural number. Yes, domain of natural number. That's why. Okay, 0 is not in the domain of natural number. That's why we cannot define that. The f circle G is not defined. Okay, na? This 0, natural number can start from the 1 only, na? 1, 2, 3. So we got the codomain 0 in 0 value is there. But that codomain is not in the natural number. That's why f circle G is not defined. That's why I have taken the, so 0 is the codomain value in the G set. But how this is valid or not? You take an input in the G value, compulsory you have to get the 0, compulsory. Then only you have to take that 0 codomain. Otherwise you can't take it. Okay, na? For this input, yes, for x is equal 0, we got the, this is actually, what is this one? Greatest integer function. Okay, na? So for 0 is also, for 0 it is giving the only 0 only. For integer values, always it is giving the integer values only. Okay, na? That's why. So 0 is the codomain value, it is not, which is not in the domain of the, yeah. Therefore, we can say that f circle G is not defined. What about G circle F? Now, I am going to the G circle F name f codomain. What is the f codomain? F codomain, yes, real value. Okay. Then, which is subset or equals to the, which one? First function domain value. The real value, yes. Real value which is subset or equals to real value. It is true. Right? So then it is the value defined. Then it is defined. How can you find the domain? This is important. G circle F domain and codomain. I already told you domain of the any composite function is the second function domain. So second function is F. F domain what is? Natural number. You can take here natural number. Now what is the codomain of the composite function? Simply the first function codomain value. What is the first function? G. G codomain is Z. That's why this is the our required domain and codomain for the composite function. In this way we can write the comment. Now after that we can find the composite function in terms of x. We already know in the first question A. So how to first remove the circle and plugging the bracket for the function f of x. Then this f of x is defined already. That f of x right side, that ln x is there na, that ln x is replace the f of x by ln x. Okay na? You can after plugging ln x, then g of ln x is there. Now g of x is function also defined. if you compare to this one, in place of x, ln x there, then you substitute in place of x, you substitute ln x. Okay, na? You can replace this x by ln x. This is the greatest integer of the ln x. We got our composite function answer. In this way we can find it.